Are you also tired of enemies that only move back and forth between 2 points? Maybe you want enemies that will follow the player. Well, then this is the tutorial for you. In this video, we will look at how we can make an enemy detect the player, follow the player, and also, at the end, give up following the player and return to its original position. We will also discuss the problems that might occur and how we can solve them. For this episode, we're going to look at a somewhat simplified but also really useful approach. But if you want me to make a video on more advanced pathfinding in Godot, then please let me know in the comments below. I will, as usual, upload the project files for this tutorial for selected tiers on Patreon. And now, let's get started. Okay, so first you need to, of course, have an enemy scene set up. This should preferably be using components, but the ideas in this video could also be transferred to other types of setups. This enemy I have made here is using the dragon sprites from the Ninja Adventure asset pack. I've left a link in the description to where you can find this. It also has components for handling, taking damage, hurting the player, and knockback effect and animations. If you want some help getting something like this set up, then you can go check out my older videos on creating the first enemy and converting your code into reusable components. However, we won't actually be using any of the things already here in this video. So your enemy don't have to look exactly like this for everything to work. So what we need now is a new component that will handle our little dragon enemy's movement. The template I have here is based on another movement component I've made earlier. In this template, we first have an exported variable for the movement speed. Then we also have an exported variable for a health component, a method that disables the component, and then these are connected in the ready method. This isn't important for this tutorial at all. It's just how this project handles when an enemy dies and needs to disable some of the components. So it's perfectly fine if you have a different setup for this kind of thing. We also have an onReady variable that sets the component's parent. This can then be used later to move the enemy. The final variable we have is a variable for storing the start position of the enemy. This is then set in the ready method using the parent variable. This template has two methods set up already that we will be expanding on. A method for updating the enemy's velocity, and a physics process method that will then update the velocity and then move the parent using move and slide. This template can also be used to create other types of enemy AI movement components if you like. Okay, so now it's time to expand this template so our dragon will follow the player. But first, let's add an instance of our movement component as a child of our enemy scene. Because we've specified a class name, we can just add it like we add any other Godot node. Back in our script, we then need a variable to store the target this enemy will follow. Since we only want to follow an instance of the player, this should be of type player. To specify the player type, remember that you need to have added a class name to your player script. If yours is called something other than player, then make sure you specify the type name you have chosen. In the beginning, this dragon enemy will just stand still. But if the player comes too close, we want it to start following the player. For this to work, we need a way for the dragon to sense that the player is close. There are probably many ways of doing this, but in this video we will be using an Area 2D to detect the player. So let's add a new Area 2D to the enemy scene, and a collision shape as the child of the Area 2D. I want my dragon enemy to detect when the player is within a certain distance, so I will be using a circle shape for the collision. But you could really use any shape you feel will fit your game. Feel free to experiment with this. I'm also renaming my Area 2D to Follow Area and removing it from all collision layers. I'm also making sure that the collision mask is set so it only listens to the layer the player is on. Now let's connect the follow areas on body entered signal to our script. Here we then first check if the body is of the player type, and then we can set our target to be the entering body. Let's then set a breakpoint here and test to see if this works as expected. We now know that this method is definitely being called when the player enters the dragon's follow area. Now let's make the dragon move towards the player. For this we need to go to our update velocity method. Here we first check if there actually is a target. If there isn't, then we just return. But if we have set a target, then we first compute the direction from the dragon to the target. Then we normalize this and multiply it with the speed to get the new velocity we want to use for moving the dragon. And finally we set the parent's velocity to be our new velocity. Now let's test again. When the player enters the dragon's follow area, the dragon will start moving towards the player. Now our enemy is following the player, which is exactly what we wanted. However, we aren't quite done yet. I'm thinking that we also want the enemy to stop following the player at some point. But when should this be? I have 3 options to show you in this video. You can use either one or maybe combine them. Or you can do something different. It's completely up to you. But please let me know in the comments below which approach you prefer. The first option is to stop following the player if it leaves the enemy's follow area. Setting this up is simple. We connect the follow area's body exited signal to our script, and here we can check if the body is our target and set our target to null if this is the case. Now let's test this solution. Okay, so the enemy definitely stops following the player, which is what we wanted. It also just continues in the last direction it used to follow the player, but we will get back to fixing this later. This solution could definitely be used in some cases, but I think that the main disadvantage is that either the enemy doesn't follow the player for very long, or the follow area that is used to detect the player should be very large. So let's try another solution. I'll just comment out the code here and add a pass while we test the next solution. Another approach could be to make the enemy follow the player for a certain amount of time. We can do this using a timer and the await keyword. But first, I will add an exported variable at the top of our script for the duration in seconds that our enemy should follow the player. Then down in the method where we set our target, we end the method by creating and starting a timer and await its timeout. When the timer is timed out, we then set the target to null. Again, we should test the solution and see how it looks. The enemy starts following the player, and after the follow duration has passed, it stops following the player. The main con here is that the enemy will also stop following the player even if it's right next to it, which seems a bit off. So, what else can we try? Well, what about getting the enemy to follow the player as long as it wants, but only if it is within a certain distance from its start position? This is somewhat similar to the first solution, but it isn't dependent on the size of the area used for detecting the player. First, we need an exported variable at the top to define the follow distance in pixels, and then in our method for updating the velocity, we first find the distance between the enemy's start position and its current position. Remember that the enemy's position is the position of this component's parent. If this is more than our follow distance, then we set the target to null. Oh, and we also need to quickly comment out the last solution we used. And now let's test again. Do you like this solution? Please let me know in the comments below. We now have 3 ways to get our enemy to follow the player. I would suggest you experiment with these, and you could also try to combine them if you like. The last thing we need to look at is getting the enemy back to its original position when it stops following the player. In our method for updating the velocity, we can add some code for when the target is null. Here we can first find the direction from the enemy to its start position. We then set the parent's velocity to be the normalized version of this direction and multiply it with the speed. And now let's test and see what happens. Now the enemy moves towards its original position whenever it stops following the player. Only, well, something is going on here when it seems to be at its start position. What actually happens here is that it might overshoot, and if this is the case, it will try to move back towards the start position, overshoot again, and so on. To fix this, we can add an overshoot limit. Let's just set it to 2 pixels here. And then if the length of the direction we computed is less than the limit, then we just set the global position of the parent to be the start position. And this should fix the problem. Our enemy is now returning correctly to its origin when it stops following the player. One thing to consider here is whether you want the enemy to start following the player again, no matter if it has returned to its origin or not. or you only want it to follow again once it has returned to its start position. Honestly, I prefer the last for most of my enemies. And this is also where it might be time to do some refactoring and separate some of our code into states to make it easier to manage what happens when. So at the top of our script, let's first create a new enum with the different states our enemy can be in. We have idle for when it's ready to follow the player, follow for when it's actively following the player, and back for when it's returning to its original position. And then we also add a variable to keep track of the current state. Next, we go to the method for updating the velocity, add a match statement, and add a case for each of the states. Now we need to separate the code here into the correct states. The first part here is for when the enemy is heading back to its origin. And the last part is when it is following the player. We can also remove the return here. When the enemy is in the idle state, we just set the parent's velocity to 0. Lastly, we need to update the current state correctly. In the back state, when we reset the position, we also move to the idle state. And in the follow state, when the enemy moves outside the follow distance, we move to the back state. Finally, down where we set the target, we move to the follow state. And if we only want the enemy to follow the player again once it has returned to its origin, we can also add a check here, so the target is only set if we are in the idle state. Now is a really good time to test again to make sure that everything still works as expected. Well, now the enemy won't follow the player again if the player is too close to the enemy start position when it returns. This is because the following starts when a body enters the follow area, and, well, the player is already within this area. So let's scratch this method here and add an onReady variable for the follow area at the top. With this, we can then check for overlaps when we are in the idle state in the update velocity method. First, we get all the overlapping areas from the follow area, and then we filter this to only get the ones of the player type. And if this isn't empty, then we set the target to be the first one and change to the follow state. Now let's test to confirm that this solves our problem. We have already covered so much in this video, but I just want to show you the last problems we need to solve and the little tricks we use to solve them. The enemy can stumble into 2 collision issues. One is when it is blocked when following the player. This way it will never get too far away from its origin to go back. And the second is when it's blocked when returning. I'm just gonna show you the solutions for both problems and explain it a bit. Then you can experiment with what you prefer on your own afterwards. The first problem can be solved by adding back the follow duration. So, how long it follows the player is based both on the distance from its origin and the time. For this, I've created two new methods. First, I moved the code for setting the target to a new follow body method. And then I also added a stop follow method. In the follow body method, I've added back the timer we used earlier. And then the stop follow method is called once this times out. For the second problem, where the enemy is blocked on the way back, we're going to use a little hack. Instead of trying to do everything correct with advanced pathfinding and so on, it's honestly very common to use various hacks. I'm thinking that we can just return the enemy to its original position if it isn't on the screen. And luckily, Godot has a node that makes it really easy to detect if something is on the screen or not. We just need to add a node called Visible on Screen Notifier to our enemy scene. And then I create a new out of sight method where we use this new node to check if the enemy is on the screen. In our update velocity method, we then add this check in our back state before we reset the enemy's position. If you want the enemy to move to the back state anytime it's outside the view of the camera, then you can also connect the new node's screen exited signal to the script and set the state to back if it's currently in the follow state. The last issue we have is when the enemy is then out of sight, but the player can see the enemy's start position. Then the enemy will magically appear. If this isn't something you like, then we can create a new Visible on Screen notifier at the top of our script, and in the ready method we add it as a child and set its global position to be the start position. Down in our out of sight method, we then also add a check for this new start visibility. The enemy will then only be out of sight if both its actual position and its origin isn't on the screen. And that was all for this episode. Now we have an enemy that can both follow the player and find its way back to its start position whenever it stops following the player. If you want to add some other behavior before it follows the player, then you can start by adding more to its idle state. But I will leave that as something you can experiment with on your own. I hope you like this video, and remember to like, subscribe, hit the bell and all that if you want to see more like this in the future. Bye!